Many of you remember us as a player in the rare earth space. We're still a believer in rare earths, but right now we're transitioning back to our roots, which was lithium. That was how it got Avalon oriented in this wonderful world, especially minerals, over 20 years ago. And I see our Separation Rapids project now as being the opportunity that's creating the platform for real growth and creating a sustainable business going forward. So that's what I'm going to talk about here today. Before I do that, remind you not to rely on any of the many forward-looking statements that I'm going to make. And you've heard this message a couple times this morning, most articulate, I think, from Amanda there earlier, but I will restate it because I don't think you can overstate this very important key messages about how different the specialty minerals sector is from the traditional mining business. And that is the kind of approach you have to take to creating a real business. Involves product design, as you heard from Amanda, working with your customers, understanding what their needs are and creating a product that will meet their needs. Doing that and using an efficient process, which in the case of minerals involves creating an innovative extraction process and trying to produce the best quality product at the lowest possible cost. In order to do that, you've got to be prepared to start that business at a small scale so you can start producing that product in small quantities, introduce it to the market, get it accepted by your customers, get those off-take commitments that will allow you to scale up and create a real business. And in this day and age, if you're going to serve the clean tech community, you better do it in a sustainable way and try to do it by minimizing environmental impacts, making maximum use of the resource, and not creating any undesirable waste materials. So those are the principles that we're going to take in creating a real business here going forward. If you're saying to yourself, boy, that doesn't sound like a mining business, that sounds like a tech business, you're right, that's really what it is. But you do need a resource, and we've had this one for 20 years now. When we first discovered it back in the mid-1990s, it was a brand new discovery of a rare form of lithium pegmatite, an LCT type of the very highly fractionated type that contains petalite and lepidolite as the dominant lithium minerals as opposed to spodumene. And we found it was a brand new find. No one had ever found a petalite resource in North America before of any consequence. And petalite is the preferred source of mineral for thermal shock resistant glass ceramics. So at that time, that was the opportunity we saw to potentially develop it, and we were on our way to doing that. But unfortunately, the market changed in North America in a way that we were not able to adapt to, and we weren't able to get it off the ground then. But I knew it would have another day. At that time, the lithium-ion battery was around, but was still in its infancy as a new technology. It wasn't a big enough market for us to serve yet, but I knew it would grow, and sure enough, we're seeing that opportunity created for us now to look at that as a new market. But as I'll show you shortly, we haven't given up on that glass market either. That's a very interesting opportunity for us still as well. But in the meantime, we've continued to do some work on it. We have a very secure tenure under a mining lease there now, 100% ownership of the asset with large land positioning, offering lots of exploration possibilities, good access, road access. We've been there so long, everybody in the community in northwestern Ontario knows us very well, a great relationship with the First Nation. And as you'll see, that's the resource outline in that photo as it appeared in 1998. Right at surface, everything in white is the pegmatite, readily amenable to development by simple open pit type mining methods. And these pegmatites, one of the benefits of them is they don't contain anything that constitutes a toxic waste material of concern to the environment. Oh. There we go. So just on our location, we're up in northwestern Ontario, about 70 kilometers north of the community of Kenora on the Lake of the Woods. community of about 15,000 people, and swells in the summer with all the Manitobans that come to their cottages on the Lake of the Woods. But good infrastructure in that both railways go through Kenora area. There's natural gas available there, and hydropower generated on the English River just downstream from us from 2 different dams that offer that possibility, as well as other potential clean power generation possibilities for us. So what have we been doing the last couple of years? Well, in the early years, all of the work was oriented towards the producing an industrial mineral for glass. We never really looked at the battery market as an opportunity. And so when we started to consider that as a possibility a few years ago, we had to kind of take a step back. And we also realized that no one had ever made a battery material from petalite before, so there was no existing process flow sheet out there. So we had to do a bulk sample, produce some concentrate again, and then create our own process, which was led by Dave Marsh, our metallurgist, who's here today. And we chose lithium hydroxide as a target for our PEA, just because that seemed to be where the best opportunity was to create a product at a competitive cost from this particular mineral. But we also know we could make lithium carbonate too, so that's one of the reasons why you want to do a demo plant, is to look at where you can best fit into the market and design the product accordingly. And like I say, we haven't forgotten about the glass market. We processed about 30 tons of ore, which gave us lots of concentrate to do that hydromet process development, but it also gave us samples to provide to the glass customers who remain interested in this material to reconfirm its suitability in some of their products. So then we did a PEA, and really the purpose of the PEA was just to show ourselves and the market that this represented an attractive economic development opportunity for this resource. It's by no means the final answer. There's quite a bit more work to do to determine what's the appropriate scale and mix of products here, but it showed us right off the bat that we could make a lithium hydroxide product from petalite, and it does produce attractive economics. The most important part of it really is the production costs, and while our average cost as determined here isn't quite as low as what Nemaska have been able to achieve, it's certainly better than others that are producing lithium hydroxide from brines, as his slide, Guy's slide showed earlier. But also of interest is we did this a year ago, and we used a price assumption of $11,000 a ton for lithium hydroxide. That's already out of date, and others are saying the pricing now is more like $15,000 to $17,000 a ton. And if you use that in our DCF model, you get quite a bit higher IRRs and NPVs. But coming back to the market, while batteries are the main story, and there's no question that's where most of the demand growth is coming from, you can't forget about these other markets, because they're still very significant and they are growing as well. And the glass market actually has been traditionally the biggest consumer of lithium. It's only been in the last year or two that battery demand has surpassed glass as a use of lithium on a percentage basis. And while it's going to grow faster, there is still growth, a lot of growth in the glass market for lithium as well, and a lot of other uses. Guy Barassa reminded me at another meeting that the use of lithium hydroxide in lubricating greases is still growing, and there's concern there about there being enough supply now. And we've heard a little bit about metal alloys, and lithium aluminum alloys is another growth opportunity. And many of these cases, it's about how lithium can make a lighter weight material, which is, we've heard already, is one of the goals in the automotive sector with electric vehicles, of reducing the overall weight of the car. And what we're finding now is that lithium can contribute to those electric vehicles, not only in the battery, but also to that weight solution. And there could end up being just as much lithium or more in the body of the car as there is in the battery. So not to be forgotten about as significant markets. Well, the glass market is one that we keep a close eye on, because petalite is still the preferred source of mineral to introduce into a glass batch. And that's because it has basically nothing else in it except lithium, alumina, and silica, which are all ingredients they need in the glass batch. So it's kind of a pre-mixed material that provides it all in a ready solution and does not contain any iron, which is a major contaminant in glass. So that's what they want. And it's increasingly hard to find as the battery industry is just basically soaking up all the supply of lithium right now, leaving the glass industry kind of scrambling for supplies and materials. And while there are traditional products such as stovetops, cookware, and fireplace shields, there's a lot of innovation happening in the glass sector too. One product you've probably heard about is Gorilla Glass, Corning's new high-strength glass product that Apple are using in their iPhones and other products now is being talked about as windshield glass. Guess what is the key ingredient to make that glass stronger? And that's just one example of a whole lot of innovative new high-strength glass products that will require lithium. And lastly, it can contribute in a positive way in terms of the environment, in that lithium additions to a glass batch for soda lime glass reduces the melting temperature and therefore the amount of energy used and greenhouse gas emissions that would come from the furnace. And the other thing we have in this resource is a second lithium mineral actually called lepidolite. That's a lithium mica. It actually contains quite a bit more lithium than pedalite does. Pedalite has about 4.5% lithium oxide on average. Spodumene is usually 6 or so, and lepidolite actually has about 8, at least it does in separation rapids. So this is actually offering us a possibility of a second lithium mineral concentrate we can make from the same resource, from which we could derive a lithium chemical as well as other byproducts, including rubidium and cesium. So we're now starting to factor this into our development plan as well. And that's a quick geological map. The area in black line as outlined there is the area I showed you in the photo earlier of the main mass of the outcrop area. But all the extensions shown in purple there are lepidolite-rich components of the resource that we've never really fully accounted for in the economics. So we're actually doing a little bit of drilling there now to update our resource to better account for that going forward. The resources as originally reported, this was based on all the drilling we did back in the 90s, just looked at the lithium content as it's traditionally reported in an NI 43-101 resource. But actually what would be more meaningful for us and for most such resources, it's actually reported in terms of the mineral content. And because the lithium actually is an aggregate of the lithium in the different minerals. So that's what we will be able to do now, thanks to the emergence of a lot of new tools, scanning technology, etc., that can allow you to differentiate between the different minerals in the resource, quantify them, and integrate that into your resource. So what are we going to do next? Well, we're going to move forward with that plan on the demonstration plant as quickly as we can. We're engaging with the downstream, talking to our customers, understanding their needs so we could establish a fairly large demonstration plant. Same kind of idea as Nemaska had. Build it big enough that you can start making enough quantity of the material to introduce it to your customers, get it accepted, and start to perhaps even supply some of their initial needs, and optimize your flow sheets to get the different products on spec. And if we're able to do that, then we could get this financed in the next little while here. We'll be able to get this up and running by the end of 2018, and gives us an opportunity to initiate small-scale production and then potentially scale up from there as we get better accepted in the marketplace, and perhaps reach full production in 2021. It's kind of a complicated slide, but it's brief. Basically, the main message here is just how many potential products that we have that we can pull out of this resource in the interest of sustainability and maximizing revenues and reducing waste. So it is a bit complicated, and that's the value of the phase 1 demonstration plant, is to allow us to produce a little bit of each and test the market, and then finally decide on what the best process flow sheet would be for this particular resource. So the next big step for us is to go ahead with this phase 1 plant. We've scaled it at 90,000 tons per year. That would allow us to produce a fair quantity of both pedalite and lepidolite, so we can start supplying our customers' needs on an ongoing basis once they've accepted the product specifications. And also start to produce some of the byproducts and test some of the other technology that can be applied. We will be looking at just starting to quarry the source, the resources you saw it there earlier. It'll be easily accessed. We see putting this demo plant in Kenora, where we've already identified an industrial site that would be well suited for it. It's actually an old paper mill, again, kind of like what Nemaska has done, is take advantage of old infrastructure that can be repurposed for this new, whole new emerging business sector. So that has all the infrastructure that we need to establish such a facility. We can truck the ore to Kenora, take the tailings back to the site for disposal, and have a hydromet component to the pilot plant to develop the processes we need to define the exact lithium battery material products that we want to produce. So we want to work with the downstream and see if we can be creative on that and define what battery industry is going to need next and work with them on developing those new product ideas. And so we have this kind of interesting opportunity to serve multiple markets from the same resource. We have the potential to make hydroxide from pedalite, we can make lithium carbonate from lepidolite, and we can make high purity lithium minerals for glass ceramics and a bunch of other byproducts to serve other markets. So it's a resource that's offering lots of possibilities, and we're on it to create most value that we possibly can for our shareholders going forward. And thank you for your attention here today.